Hello, I'm Cy, the IT guy Williams, the owner of Team Logic IT of Orlando. Welcome to the Florida Medical Allstars Expo presentation on blockchain, smart contracts, and healthcare use cases. We can't really have a discussion about blockchain without first talking about Bitcoin. Blockchain made its debut with the introduction of Bitcoin in 2008. Bitcoin is a first-generation blockchain. Ethereum is a second-generation blockchain. Ethereum addressed some of the architectural limitations of Bitcoin. It enabled the tokenization of assets, and it implemented what's called smart contracts, which is a fully programmable way to automate transactions and enforce contractual obligations. So during this presentation, we will provide an overview of blockchain-based distributed ledgers. We'll discuss how blockchains and smart contracts work. We'll explore the benefits of blockchain and discuss blockchain healthcare use cases. So ledgers have been around for some time. A ledger is a tool for financial accounting, a tool to track what you own, who you owe, and who owes you. Ledgers have applications beyond financial accounting. Distributed ledgers using blockchain technology can lower the cost of tracking and exchanging financial and non-financial assets. So what is a blockchain? A blockchain is a distributed ledger, a ledger that exists on multiple machines in a network, where each machine in the network has a complete and full copy of the ledger. While it's a distributed ledger, it's maintained by computers. The computer programs use consensus algorithms to agree on the state of the ledger. Proof of work and proof of stake are the two common consensus algorithms used. This presentation is based on the proof of work consensus algorithm. Blockchain networks are secured by cryptographic techniques, including hashing and public key encryption. A cryptographic hash is used to validate data and link blocks of transactions together. Public key encryption is used to sign and validate transactions. Hashing and public key encryption will be discussed in greater detail later in this presentation. While hashing and public key encryption secures the ledger, the consensus mechanism makes the ledger incorruptible. All transactions on the ledger are visible, making it transparent, and transparency is a key element to establish and maintain trust. A blockchain is a mechanism for establishing trust without intermediaries. In the past, banks have assumed the role as a trusted third party. Blockchains have built trust into the system, enabling the elimination of intermediaries such as banks. Bitcoin demonstrated that trust can be created using software. So blockchains keep a record of all transactions that have ever occurred on the blockchain. The complete transaction history allows for verification of asset ownership programmatically. Every node in the blockchain network verifies every transaction for accuracy. The programmatic verification of assets can reduce the cost of verification across multiple industries. Industries or processes that require data verification may find blockchain technology use cases that lower their cost of verification. So in summary, Bitcoin was the first cryptocurrency to implement blockchain technology. It's considered a first-generation blockchain. Ethereum is a second-generation blockchain that enabled asset tokenization and initial coin offerings. The third-generation blockchain's characteristics is still to be determined. The third-generation blockchain may be characterized by the integration of blockchain platforms. So let's talk about the blockchain network. A blockchain network is a peer-to-peer network that consists of wallets and nodes. A wallet can be a mobile or web-based application. It has an address that can be the source or destination of a transaction. Wallets are used to create transactions, cryptographically sign the transactions, and communicate the transaction to the nearest node. Bitcoin is a permissionless blockchain, which means that anyone can download the software and participate in the mining process. Anyone can become a node. Permission blockchains require authorization or approval before someone can participate in the mining and become a node. A blockchain is a distributed ledger, a ledger in which each node has a copy of the entire blockchain. All of the nodes verify all transactions and all blocks. The blockchain is a peer-to-peer network, which means all communication is between nodes and there is no central node controlling everything. Nodes receive transactions from wallets and peers. All of the transactions are visible on the network. The address associated with the source and destination of the transaction provides users with pseudonymity. And consensus mechanisms make it impossible to alter past transactions. Miners play a key and critical role in blockchains. The miners validate all transactions. They bundle validated transactions into blocks. They chain the blocks together by inserting the hash of the previous block into the new block. They find the hash for the new block. They add the new block to the local copy of the blockchain after they found the hash, and they notify the peers about this new block. There are three types of blockchains. A public blockchain is a permissionless blockchain, which means anyone can download the software and participate in the mining process. A private blockchain is a permission blockchain. Miners require permission or authorization before they can participate in the mining process. And a consortium blockchain is a type of permission blockchain, one where multiple companies are working together to deploy a blockchain solution and establish the network. So blockchains use hashing extensively to verify data without revealing the data. A cryptographic hash is a one-way translation of the data. Hashing routines take data input of any size and create a fixed length output. The hash can be considered the fingerprint of the data. The National Institute of Science and Technology has published secure hash algorithms, referred to as SHA algorithms. Bitcoin uses secure hash algorithm SHA-256, and Ethereum uses secure hash algorithm SHA-3. So here's an example of a secure hash algorithm. One of the key characteristics of a good hashing routine is that a small change in the data results in a significant change in the resulting hash. So if you look at this phrase, your managed IT service provider, the characters below that is the hash of that phrase. In this example, if we change the uppercase y to a lowercase y, we result in a significant change in the hash value for that phrase. So hashing techniques are used to validate data without revealing it. They provide the basis for immutability. Any change to a block will change the block's hash value and invalidate all succeeding blocks. Invalid blocks won't pass the validation check of peer nodes. Consequently, peer nodes will not add this change to their local copy of the blockchain. Nodes work on blocks where 51% or more of the nodes have accepted the chain of blocks as valid. The longest chain of blocks in the blockchain is considered the valid chain. So let's talk about public key encryption. Public key encryption is a system that uses mathematically related keys. There's a private key, which should be known only by the owner, and a public key, which can be known by the public. Wallets use the private key to digitally sign all transactions. Nodes use the public key to validate transactions. There are some limitations of Bitcoin. There's a bunch of new concepts. There's cryptography that can trip some people up. There's a need for a large enough network so you can have adequate security. There's a transaction limit, a number of transactions that Bitcoin can handle per second limit. There's if you want to use Bitcoin for microtransactions, maybe to come from IoT devices, the cost per transaction may be prohibitive and not allow that to occur. And then because Bitcoin uses proof of work consensus algorithm, it's vulnerable to a 51% attack. So let's talk about smart contracts. Bitcoin had a scripting language that wasn't complete. It's called Bitcoin script. Smart contracts was introduced to fix the problems within the Bitcoin scripting language to make it a complete language. The main thing that was missing from the Bitcoin scripting language was the ability to run loops. And so Ethereum has the ability to create smart contracts. It has a complete software programming language, and more importantly, you can create loops. What that does is enable a wide variety of functions and capabilities in software that really requires loops in order to accomplish those tasks. The software in the smart contract executes on all of the nodes of the blockchain network. The execution of that software is triggered by changes to the state of the blockchain. Smart contracts are typically set to automatically enforce contractual obligations. So what is a smart contract? A smart contract is a special type of account on the Ethereum blockchain network. It's an account that is managed by software. It's a software managed wallet. The account owns the ether, it owns the storage, and the code that controls the account. There are some limitations of smart contracts. They're better suited for pretty deterministic agreements. They're better suited for transactional type contracts, and they're not well suited for relational deals. There's some limited flexibility. Remember, the blockchain is immutable. Smart contracts become transactions, become items on the blockchain, so they're immutable as well. So it limits in terms of flexibility and deployment, and it drives up the need for testing and validation of smart contracts. Of course, just like any programming language or computer code, it's subject to bugs and coding problems. Real estate on the blockchain can eliminate the need for title insurance and escrow services, provenance and authenticity tracking, enable tracking of precious metals like gold and diamond, and eliminate fraud and guarantee authenticity. Supply chain, real-time visibility for every step within the supply chain. Royalty payments, automating the payment of royalties based on asset use. And of course, healthcare, permitting individuals greater ownership of their digital identities and greater control and disclosure of their personal health information.
Hello, my name's Anessa Santos. I'm an attorney practicing in Orlando, Florida. My area of expertise is corporate law, intellectual property, and securities for emerging technology companies. I'm here today to talk to you for blockchain for use in healthcare. I'm going to talk to you about smart contracts and how they may improve patient care. In 2016, the United States Department of Health and Human Services announced an ideation challenge. And in that, we requested white papers examining how blockchain could change health information technology. And as a result, there were 77 submissions and 15 awards were given. Congressional Representative David Schweikert from Arizona works with institutions like the Massachusetts Institute of Technology and the National Institute for Standards and Technology to develop encryption standards that would protect the private medical data of Americans registered on a blockchain. Around August 17th of 2017, Representative David Schweikert did a podcast with the Joint Economic Committee in which he stated that medical records have no value if they don't move with you. So think, if I could put my medical records on a blockchain where, just like on many phones, I could use my thumbprint and a password, and well, with a certain type of encryption, it would be HIPAA compliant, and all of a sudden, you and I and the rest of society can carry all of their medical records just on their phone. Well, as we all know, either from working in the industry or just from being patients, recipients of medical care in our current system, the state of managing healthcare records is completely fragmented and it's bottlenecked due to a lack of shared infrastructure or common standards. What's really exciting about blockchain is that smart contracts aren't contracts that are written by really smart lawyers like me, but they're contracts which can be automatically executed on a blockchain, similar to when you download a software program from the internet and it just automatically executes itself on your computer. Smart contracts that are stored on a blockchain contain computer programming language, establishing conditions precedents, conditions subsequents, and so when they read that a condition has occurred, it just automatically moves on to the next line of the code, continuing to execute the commands. And so if we employed these on the blockchain, we have the potential to improve treatment by providing more accurate diagnoses, treatment choices, and cost-effective care. They can also be used for supervising drug intake and distribution. It can regulate compliance, or it can even manage healthcare supplies. Patient data, obviously, should be encrypted on the blockchain, and it would only be accessible with a private key that links the patient's identity to their records. Patients can share their private key with new healthcare providers, while the data remains encrypted to those who do not have the key. The information can be redirected to the blockchain via application programming interfaces and processed by smart contracts. What's an application programming interface? Well, you know how sometimes when you log on to a new site and it says that you can log on using your Facebook information or maybe your LinkedIn account. But it's not the Facebook site or it's not the LinkedIn site, right? But when you click on Facebook, it goes and it pulls your information from Facebook and uses that to log you onto a new site. That would be an application programming interface. So we would be able to utilize APIs, and if we can process smart contracts with other healthcare providers, which can directly query using your patient's key. The Department of Health and Human Services, Office of National Coordinator for Health Information Technology. There were 4 points that they wanted every participant who submitted a white paper in response to the ideation challenge that they wanted them to address. And this is really important, right? Because this is what the Department of Health and Human Services has identified as the major factors that they're calling on wider industry participants to help them with. The first one is that they want folks to explain how blockchain can be used to address concerns about privacy, security, scalability of health records. This is particularly important to me as a patient from time to time when I get really annoyed when I have to actually go to my doctor's office, pick up my records, get in my car, and drive to the next location to drop them off. I'm thinking, this is crazy. And so by engaging in the process of researching for this presentation today, I learned why that is. Well, it's because information is being kept in silos and the infrastructure isn't shared. And that's why I have to physically pick things up and take them to the new location. So the first point that they wanted folks to address in the ideation challenge was, how can we address scalability while still maintaining privacy and security? They also want folks to discuss cryptography, the underlying fundamentals of blockchain technology, to be able to exemplify that they can demonstrate a real understanding of the underpinnings of how blockchain works, and so that they have thought it through as to how they can address some of these concerns of the Department of Health and Human Services. The third point is they would like for them to examine how the use of blockchain can advance industry interoperability needs that were previously expressed in the nationwide interoperability roadmap. They also want them to explain how blockchain can affect patient-centered outcomes research, precision medicine initiatives, and other healthcare delivery needs. And then finally, they're supposed to provide recommendations for blockchain's implementation. The healthcare industry interoperability objectives were of prime importance in the ideation challenge. You may be aware that the Nationwide Interoperability Roadmap is a rather substantial document of 94 pages, and it's intended for health IT stakeholders who will build the infrastructure necessary for interoperability and for those who will use that infrastructure. So hopefully, when we see the implementation of some of these ideas that we're going to review here shortly, I won't need to have to physically go and pick up my records and move them. I'll just be able to share them at will. The patient-centered outcomes research compares the impact of 2 or more preventative, diagnostic, treatment, or healthcare delivery approaches on health outcomes, focusing on those that are meaningful to patients. And the Precision Medicine Initiative pioneers a new model of patient-powered research that promises to accelerate biomedical discoveries and provide clinicians with new tools, knowledge, and therapies to select which treatments will work best with patients. We're going to be discussing selected summaries. You might recall that I mentioned that there were 15 winning white papers, and I reviewed them all in extensive detail to give us sort of a 30,000-foot view of the summary of the 15 winning papers in answer to the ideation challenge. An overarching theme that I was able to identify throughout them all was that blockchain transforms the healthcare system. It can aggregate patient data for population health profiling, which is really important even today as we think about in the recent news that there is a new polio-like virus that's attacking children and now even adults. It can improve communications and logging that eliminates data disputes. It can transform patient data as a service, providing interoperability of systems, health applications deployed and executed over shared infrastructure, access to healthcare data provided by new patient devices, such as wearables, and it can provide new ways to connect patient data silos. We're going to talk about the National Quality Forum, and what they really focused on was wearable devices via the Internet of Things and how we can connect our devices over the internet to create greater human value. And as blockchain becomes the backbone for digital health by incorporating data from patient-based technologies and electronic medical records, it can provide a comprehensive pool from which authorized users, like providers and patients, have access. And so the National Quality Forum was really impressive to me because before I was asked to sort of put this presentation together, I literally had really no idea about the myriad of uses that blockchain had for health information technology. And so when I came upon the National Quality Forum's white paper, I got to thinking about my own personal experiences with healthcare and my loved ones and this whole, wearable devices and the Internet of Things. And I thought about my aunt. And my aunt, she had had multiple back surgeries many, many years ago. And, it didn't go well. And so she actually had a morphine pump implanted in her body. And when I thought about how if her morphine pump had been connected and on all the time, recording and providing immutable records of, when she needed to release additional morphine and the effects that she was having and all of these monitoring devices on her, how incredibly helpful and beneficial that would have been to her care. And so the National Quality Forum obviously thought about that too, because they really focused on patient-related outcome measures regarding wearable devices connected to the Internet of Things that would all be tracked, traced, and recorded on a blockchain, all of the data from the wearables. That would have been amazing. I would have loved if my auntie would have had access to that. It could have also facilitated greater patient involvement in treatment decision-making and guidance for healthcare decisions, which is really difficult to do when you're in a morphine fog. I think that all of us, and in these days, know somebody that maybe has suffered from cancer. And if we think about, sort of the expansion of these wearable devices that we can attach to people so that they can receive better quality treatment for better patient outcomes in their home, remote from their doctors, we can all agree that the benefits that we could achieve that have been identified by the National Quality Forum are just outstanding and far outweigh any of the disadvantages that anyone could possibly identify. We're taking a look at Laura Lynn and Dr. Martha Koo and their concept for how blockchain can be used for health data and its potential use in health information technology as well as healthcare related research. In the American Recovery and Reinvestment Act, it required all healthcare providers to adopt electronic medical records by January 1st, 2014, or they would lose Medicaid as well as Medicare reimbursements. And so while most complied, the vast majority of electronic medical records management systems do not have the capability of sharing health data. When I read this, I was like, aha, that's why I have to drive and pick up the medical records. It's really funny because just a couple of months ago, I was back home with my mom and she had a shoulder injury, right? We had to actually go to the urgent care, pick up the medical records and, take it to the next location, her physical therapist. A blockchain-based access control manager for health records would advance industry interoperability, which is a critical component of any infrastructure supporting patient-centered outcomes research, as well as the Precision Medicine Initiative. So a national health information technology infrastructure based on blockchain will promote precision medicine as well as advanced medical research and prioritize patient involvement in their healthcare objectives. How? Well, we kind of take a look at the diagram, right? And so in their paper, we saw these elements of, sort of these illustrations, if you will, about how health information from providers and data from personal devices and sensors could be shared in this sort of an infrastructure and how everybody can access and see what's going on. So if my auntie had biosensors on her, right, we could be checking the blood pressure, the same thing, MRIs, her prescriptions, the doctor's reports, maybe if she had a heart monitor, lab results, all of this could be encrypted as well as with a digital signature. And well, back to Representative Schweikert from Arizona, we could carry it all around on our phones and access it maybe using a thumbprint or some other biometric authentication identifier and maybe a private key password, and we could share those portions of our records that we want to with other healthcare providers. And so on a health blockchain, it would list all the health records and data that have been collected throughout the patient's life, from cradle to grave. And the type and location of the data would also be necessarily included. And the data lake, if we look at sort of the illustration right beneath that one, all health data could be stored in a data lake, right? And so each blockchain transaction stores the location of the health data that it references. Drew Ivan was another individual who talked about a blockchain-based solution, that it may be an option at some point in the future, but that a near term requires a bridge solution. I think it was Accenture that talked about the possibility of how blockchain could sort of come alongside existing infrastructure, and it doesn't have to be a rip and replace solution. And I think this is really critical for health providers to understand, right? Because when we think about the existing infrastructure and how incredibly magnanimous that it has grown, and all of the resources and the money and the expertise that has gone into building out these infrastructures, honestly, I mean, I don't work full-time in the industry, but I have to say that I don't really think that it's financially feasible to rip and replace. And so that's the great news. We have several parties who won the ideation challenge with their winning white papers, including Drew Ivan, who say it doesn't have to be. We don't have to rip and replace it. This is something that we can integrate into existing systems. And we can do this, according to Drew Ivan, as we move toward a blockchain-based method for the secure storage of patient records. I pulled a quote from his paper that I thought was really important. And he says that today's methods of recording and sharing patient data have a number of limitations that restrict patients' access to their clinical records, while reducing availability of essential data to care providers, and ultimately presents a barrier to transforming U.S. healthcare into a learning health system. And so while electronic records were supposed to, the whole idea behind EMR was that it would provide a secure, trusted, and efficient solution to record sharing, the information silos that we have between various providers' data infrastructures, they're nearly impenetrable as back when we just used paper records. And he went on to discuss something that I actually didn't even know was a problem before I engaged in the analysis and research for this presentation. He identified this concept called information blocking. And so maybe you know about that, but I didn't know about it. And it's a situation where healthcare providers who are erring on the side of caution, they restrict patients and their proxies from accessing data about their own health. And apparently, this problem is so widely pervasive that the Office of the National Coordinator has actually identified procedures to correct these instances of information blocking. If we were to utilize a blockchain, what's really exciting is that we can actually make the patient the primary custodian of their own health records, and to contribute to that information as well as direct it to any electronic location. So this is amazing. This is exciting to think that I'm the primary custodian of all of my healthcare records, and I can access my own health history at any time I choose, and I can provide access to maybe my emergency contact, whether it's my mom or my son or my husband or whoever else it is. How incredible would that be if I were in a major car accident, right? And they need to provide emergency care. I really need folks to know that I have a sulfur allergy, right? And I can't be administered certain kinds of medication. But the physicians would have no way of knowing that. And if they were to ask for my previous records, the other healthcare provider would have 30 days to provide it. So by that time I would be long dead. So I think this is an amazing issue that I'm really glad that Drew Ivan identified, and that he has determined about how the utilization of blockchain in our existing infrastructure can solve this pervasive problem. I was really interested to learn about this issue of Medicaid churning. I didn't know about this, and I was like, you've got to be kidding me. This is the most inefficient thing I've ever heard of. So at the Institute for the Future, at the Blockchain Futures Lab, they discussed a blockchain profile for Medicaid applicants and recipients. They discussed the Smart Health Profile, which is a pseudonymous approach to a distributed identity, identifying the problem of Medicaid churning, which, as I learned by reading the white paper, is the constant exit and re-entry of beneficiaries resulting from eligibility changes. So if you're not familiar with this system, Medicaid eligibility is really complicated, and it's determined by income thresholds and financial guidelines that require up to 45 days to verify eligibility. And then once eligibility has been identified, or even during the process of identifying a person's eligibility for Medicaid, if the circumstances change, the recipient has to start the process all over again, which is kind of stupid, right? So it results in a turnover so that the average adult on Medicaid actually only receives an 80% of coverage time. And so the system is completely overburdened with unnecessary administration because you have to start the process all over again each time any of your eligibility changes. And if we were to apply blockchain, then we have the potential to create a profile, which is not just a repository of static information about a person, but we could actually create a dynamic information oracle that provides on-demand access to specific information that may reside anywhere. What is an oracle, right? So Sai touched upon this, and just to kind of refresh our recollection here, because it's really pertinent to this issue, let's say that you and I make a bet on the Gators, right? I'm in Florida, so I'm obviously a Gator girl. And if the Gators win, you owe me $50, and if the Gators lose, I owe you $50. And so let's say we create a smart contract that says that, right? So it's written in programming code that if the Gators win, then the $50 comes out of my account and transfers into your account, and the account information has already been written into the programming code. And then the reverse, if they lose, then the $50, if I win, it goes from you to me, and if I lose, it goes from me to you, right? You get it. But an oracle determines, how do you write into the smart contract if the Gators won, right? So that's kind of like the missing element, and that's where the oracle comes in. And so we tell the oracle that it's going to check ESPN, because I'm making that up for the purposes of this illustration, right? So on, the date certain, at the time certain that we've programmed into the smart contract, it goes out, it checks ESPN, and whatever ESPN says is the final score determines who won the bet and then the transfer of the $50. That's how oracles work. And so about this whole Medicaid eligibility process, if the oracle were to set up to kind of look through the person's account, and maybe sort of check certain other factors in the life, and so the person could connect up maybe their savings account or their checking account or whatever information. And so what's really interesting about this is that the Medicaid administrator, the person behind the desk, that individual person, they wouldn't have the ability to actually look into the Medicaid recipient's actual checking account or savings account or whatever the oracle was looking at. So this would all be blind information that we could trust the oracle to provide to Medicaid. And so it could automatically update the eligibility within Medicaid. And so then within moments, remember how we talked about earlier, how we could resolve insurance claims for healthcare benefits to be resolved within minutes, right? Just as I'm leaving the doctor's office. Imagine if we can set up a smart contract on a blockchain with the utilization of oracles to the necessary means to determine eligibility, and within moments, right, that person's eligibility for Medicaid could automatically be changed, and thereby we could reduce the substantial burden of overhead that we have for folks in the system that are reprocessing claims. These smart profiles that we could set up can provide a series of services in order to access all kinds of encrypted information about the recipient as well as beneficiaries of the plan. And you can even limit it to make it available only for certain and specific circumstances. It can notify the users when their status changes, and it can automatically apply for benefits or other insurance options based upon those changes. Concerns about data integrity and validity can be addressed with these Oracle services, and it can be used to build a consensus of multiple data sources amongst an entire network of oracles, thereby successfully addressing the entire issue of Medicaid churning. We are going to talk about MIT Media Labs and their relationship with the Beth Israel Deaconess Medical Center. And you might notice that there is a giant gold check mark on this page. And the reason why you're going to see this big gold check mark on the page is because this blockchain is in development, folks, and this is what is really exciting. The name of this blockchain between these two partners is the MedRec blockchain, and it's being built out on the Ethereum, remember that's our second generation blockchain network. And it addresses fragmented access to medical data, system interoperability, patient agency, and improved data quality and quantity. It's a novel, decentralized record management system that has been designed to handle electronic health records using blockchain technology. It gives patients a comprehensive, immutable, remember that means unchangeable, log, as well as easy access to their medical information across providers and treatment sites. It manages authentication, confidentiality, accountability, and data sharing, while enabling data economics by supplying big data, remember stripped of personally identifiable information because it's pseudonymized, to empower researchers while engaging patients and providers in the choice to release metadata. Miners on this particular blockchain, and Sai talked about the role of mining in blockchain development, they would be incentivized in the MedRec blockchain with access to huge stores of aggregate anonymized data. And so this kind of harkens back to the idea where the health information blockchain should probably be a private blockchain, right? A larger consortium blockchain. And so folks that would have access to these huge stores of aggregate anonymized data would be stakeholders in the health industry. And so if you had like a gigantic research institution, right, they might want to have miners on the blockchain, and their incentive to invest in all of the equipment and the resources necessary to mine the blocks of data that are being stored on the blockchain would be that they have access to the stripped data, the pseudonymized data, that continues to fuel and provide additional data sources for their research. And then finally, this MedRec Ethereum-based blockchain solution would integrate with providers' existing local data storage solutions, which facilitates interoperability and adaptability. And so folks, this really harkens back to the issue that this is not a rip and replace system. This is something that can come alongside, build on top of, work with your existing IT infrastructures. We see another gold check mark, and that's because the Mayo Clinic, well, they have an actual blockchain in process, and they talked about the blockchain-based approach to health information exchange networks and how blockchain can resolve barriers to adoption of cross-institutional sharing of healthcare data. So, as we've discussed, data sharing raises privacy concerns. Security, auditability have to be guaranteed. The patient, as we can all agree towards the end of this presentation, right, has to be in control of their own records, and they can authorize who has access and when. There may be some concern amongst industry players out there that data sharing could give other competitors an industry advantage. But what's really great about this proposed system that I think that all of the winning papers seem to agree upon is that blockchain can ensure an ecosystem where every single participant has equal access. So nobody gets the winning leg up. And so while we currently today do not have any industry consensus around infrastructure, so remember we talked about how we would need to have data standards for data entry and data access, similar to what we're familiar with ISO 27001 standards. We would need to apply something similar to healthcare data. The fast healthcare interoperability resources is under development, and that will be the emerging standard to depict data formats, elements, and application programming interfaces. So I was really excited about this, right? Because as I was reading through all of the white papers, which I have delivered in the order in which they were provided on the Office of National Coordinator Health Information Technologies website, by the time I got to this paper, because I was really concerned about these data standards, and then I got here, towards the end of the winning white papers, and I was like, aha, right? People are already working on this. So folks, this is happening, and that is what is really exciting. And so, of course, sharing data requires agreement about data syntax as well as structures and meaning, and so all of these issues are being addressed. And so what's really neat, which is not available out there on the internet because I have inside information, folks, is that the medical chain, blockchain, and you see another gold check. What's really exciting about this is that there is a new relationship between the Mayo Clinic and the medical chain. And I know this because I work in an office sharing environment, and another company that's on my floor is actually the digital media and marketing company for medical chain out of the UK. And they're like, oh yeah, they've partnered up with the Mayo Clinic, right? They're helping a bit out this blockchain. And I was like, no way, this is so incredibly cool. So folks, this is available today. The Mayo Clinic together with the medical chain. And medical chain, prior to the partnership or the relationship, back when they were producing the ideation challenge and prior to sort of their substantial launch, they use blockchain technology to securely store health records and maintain a single version of the truth, right? That version of the truth, which has been stored and executed on the blockchain, so that different organizations like doctors, hospitals, laboratories, pharmacists, health insurers can request permission to access a patient's records to serve their own purpose and record transactions on the distributed ledger. Remember, that's our blockchain. It's a distributed ledger. And so medical chain provides solutions to today's health record problems. The platform is built to securely store and share health electronic records. By digitizing health records, we can empower the users and we can leverage countless industry synergies. So folks, I really hope that you've enjoyed today's presentation on the wonderful world of blockchain and the myriad ways in which it can resolve today's problems in the healthcare industry overall. If you've got any additional questions or comments, then I would really hope that you would reach out to Sai or to me. You can find me at intellalaw.io, that's INTELLILAW.io, or feel free to look me up on LinkedIn. Thanks everyone.